Hi students, in this video we are going to cover vector and scalar quantities. A variety of quantities that are used to describe the physical world. Examples of such quantities include distance, displacement, speed, velocity, acceleration, force, mass, momentum, energy, work, power, etc. All these quantities can be divided into two categories as vector and scalars. A vector quantity is a quantity that's fully described by both magnitude and direction. On the other hand, a scalar quantity is a physical quantity that's fully described by just its magnitude. Now, let's divide these quantities as vector and scalar quantities. For example, distance is a scalar quantity while displacement is a vector quantity because it has a direction. Speed is a scalar quantity, but velocity is a vector quantity because in velocity there is direction. Acceleration is a vector quantity. Force is a vector quantity. Mass, no direction, a scalar quantity, while weight has a direction into the center of the earth, so a vector quantity. Momentum is a vector quantity. Energy, work, power are scalar quantities. Vector quantities are often represented by scaled vector diagrams. Vector diagrams depict a vector by the use of an arrow drawn to scale in a specific direction. You see in the example that we draw an arrow in a specific direction. In drawing a vector, a scale should be clearly listed. Here is my scale. It represents that 1 centimeter is equal to 4 meters. This is a displacement vector. So the length of the arrow represents the magnitude of the vector. So the displacement has a magnitude of 20 meters. So if this is 20 meters, then the length of the vector should be 5 centimeters. We have a tail, this is the beginning of the vector, and this is the head of my vector. And you hear it has a direction showing the degree 30 degrees north west of north. In order to represent a vector, we use a letter with an arrow above it. We use a capital letter with an arrow about it. In order to show the magnitude of a vector, we use the symbol with an arrow and put it in an absolute value. This represents the magnitude of the vector. So here I can say that, let's say this is a B vector and the magnitude of the B vector is 20 meters. An example given the scale 1 centimeter is equal to 5 meters per second represent the vector 35 meters per second 45 degrees east of north by a scaled vector diagram. As 1 centimeter is equal to 5 meters per second, then 35 meters per second will be equal to 7 centimeters. Now this is the length of my vector. This will give the direction. It is 45 degrees east of north. This is north and this is east. So 35 degrees east of north will be in this direction. And this will have a length of 7 centimeters. So I have drawn my vector. The properties of vectors. 1. Equality of vectors. Two vectors are equal if they have the same magnitude and the same direction. So you see here that we have three forces. They have the same length and the same direction. so they are equal. These three vectors also, they have the same magnitude and direction, so these three vectors are equal. Two negative vector. A negative vector is a vector that has the opposite direction to the reference positive direction. So I see here that A and B are equal vectors because their direction and their lengths are equal. But here A and C have the same magnitude, but C is in the opposite direction of A, so A is equal to minus C. You can shift a vector in parallel without changing its direction and magnitude, still have the same vector. So here you see that this is my A vector and this is my negative A vector. They have the same length but just opposite in direction. Adding and subtracting vectors. The addition and subtraction of vector is also a vector. When vectors are added, we are needed to take into account both their magnitudes and direction. If they have the same direction, so we sum the vectors, the magnitude of the vectors, and the sum of the vectors will be in the same direction of the previous ones. If they have opposite directions, let's here say that F2, the magnitude of F2 is bigger than the magnitude of F1. So I have to subtract them because they are in opposite directions. So the total force or total vector will be in the direction of F2 because its magnitude is bigger. Multiplying the vector A by the positive scalar C is equivalent to adding together C copies of the vector A. Thus 3A means A times plus A plus A. Multiplying a vector by a scalar will get you a vector with the same direction, be careful about it, but different in magnitude. So this is my A vector. 3A means summing the 3A vector, so they're at the same direction. So this vector has the same direction of the A, but 3 times its magnitude. If C is negative, then the direction of A is reversed by scalar multiplication. So if I'm going to find the minus 2A, minus shows me the negative direction. So this means that the magnitude is 2 times but in opposite direction. You see here that the magnitude of minus 2A is 2 times, let's say A to A, the original one, and opposite in direction. Distributive property, 2 times A plus B is equal to 2A plus 2B. It has the commutative property, A plus B is also equal to B plus A. Now let's solve an example which one or ones of the given statements is or are true. A vector is equal to B vector. Let's look at here. They have the same magnitude but opposite in direction, so it is false. D is equal to 2C. D and C has the same direction. D has 4 segments and C has 2 segments, so it is true. F is equal to 2B. F and B doesn't have the same direction, so it is false. The vector A is equal to vector E. Vector A and D has the same direction with the same magnitude, so it is true. The vector E is equal to G. E and G don't have the same direction, so they can't be equal. the magnitude of E is equal to the magnitude of B. Now let's look at here. The magnitude of E and the length of the magnitude of B are equal. They are not equal vectors, but their magnitudes are equal, so it's true. Draw the given vectors. We have the vector with the x component 8 and the y component 6. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So I have the head of my vector here and draw the vector like this. Now let's draw the vector C. It has the x component 4 and the y component minus 6. Now x has 1, 2, 3, 4 and y 1, 2, 3, 4, 5 and minus 6. So here I find the head of my vector and draw from the origin like this.